Alright, in this video we're going to take a look at activity 216, step-by-step truss calculations. We're going to look at number 5. I've already got the truss structure drawn. And we're going to be following the same process, the same 5-step process that we did in the last video to create and calculate our truss calculations. So start off, step 1, we're going to draw the free body diagram. And here, I'm going to leave a little bit of room here between our label, because I've got a few y direction forces. I'm going to go ahead and start off with drawing the truss members and joints. And I'm going to start to note, first off, before I start putting in joint letters, I need to look at my pin and roller connections. It's very similar. This is going to be set up against a wall. So the pin is going to fasten us against the wall, and it's also going to support us in the Y direction. Now this is joint E, so this is going to be REY. And this one going to the right is going to be REX. So these are reactions at E in the Y direction, reactions at E in the X direction. And then the roller is going to, just very similar how it did before, going to keep us pushed up off of the wall that we need. And this is going to be RDX, since this is joint D. Joint B, A is going to be here, and off to the side I'll put C. So because we've also got two 500-pound forces acting downward on joints A and C. And then what I got to also take a look at are my distances. So I'm going to go ahead, I'm going to leave a little bit of room here. This is going to be 2 foot. This will be 2 foot. And just as a note, this is 4 feet. The only thing we're going to kind of be missing as I kind of scoot the paper over is we may need to know what are some of the angles. So like in this case, like I may need to know this angle, and as I start to look, I know the opposite side, I know the adjacent side. So very similar like how we did, we're going to use tangent of theta is equal to opposite over adjacent. Tangent of theta is equal to opposite side. We know the height of this is going to be 2 foot. The adjacent side of the triangle from the angle is going to be another 2 feet. So if we know this is 2 feet, that means the rest of this must be, if the overall is 4 feet. And I'm going to end up doing the inverse tangent to go through and solve for. And I'm going to kind of, let me section this off, that way I don't run into anything. And I'm going to get the same kind of scenario. It's what I did last time. So just a little hint, anytime you go through and have the inverse tangent of anything that gives you 1, so like here 2 divided by 2, 3 divided by 3, like in the last one, you're always going to end up getting theta is going to be 45 degrees. So there's just a little side calculation to determine any angles. I know this one's going to be 45 degrees. I can safely say, looking at this angle and also at this angle, alternate interior angles in this case. So this is going to be 2 and 2. This is going to be 45 degrees. Same thing with this one. And that's going to make that pretty easy to go through and to be able to solve for. Okay. All right, step 2. Step 2 goes through and has, we are going to sum the moments. And very similar like what we did, sum of the moments add up to equal 0, and moments are calculated by taking force times distance. So the thing is, I need to, again, put my finger on the pin. That's our point of pivot. I need to look at what forces are going to cause a rotation. 500 pounds acting downward is going to make this spin in this direction. Now, this is going to generate a counterclockwise moment. So, however, I like to go through, I'm going to kind of almost flip the x direction in this case. So when I flip the x direction, actually going to the left is going to be positive, going to the right is going to be negative. And there's a reason for that, and we're going to see kind of why I've kind of flipped it. So I'll go through and kind of make that happen. I might want to make a little note up here that for the x, left is positive and right is negative. Okay, so because of this is going to go through and cause, and it's because of this rotation. So since this is going downward, negative 500 pounds times, it's 4 feet away, again the perpendicular distance to where the force is being applied, times 4 feet, plus, as I look at the next one, 500 pounds acting downward, it's going to generate the same kind of moment, negative 500 pounds. So I want to go through and label that as being a negative force, times 2 feet. And then the only other force that I have that would help counteract that is going to be RDX, pushed into the left, which what I just said about the directions, RDX times, and it's going to be 2 feet away. And when I add those together, they're going to equal 0. So I'm going to start to do some simplification. Negative 2,000 pounds, 500 times 4, plus negative 500 times 2 gives me a negative 1,000. And then plus RDX times 2 feet, which is equal to 0. I look at combining some like terms. So here I've got a negative 3,000 plus RDX times 2 feet equal to 0. I'm going to add 3,000 to balance the equation. RDX times 2 feet, which is equal to a positive 3,000. Pound-feet would be the units there. Divide by 2 feet. And RDX is going to be equal to a 1,500 pounds of force. So that's how much that RDX is going through and supplying. So I can put underneath there 1,500 pounds. That's how much it's pushing on joint D to keep it supported. Step 3. Sum the Y forces. Okay. Again, looking at Y direction forces, I do have, let's put my equation, sum of the forces in the Y direction add up to equal 0. I've got REY acting upward, so that's a positive value. And then the only other ones I've got are these two 500s that are acting downward. So plus a negative 500 pounds plus a negative 500 pounds. So I need to count for both of those separately. And when I add those up, all three of those forces that I have identified in the free body diagram, I'm going to go through and have them add up to equal 0. Okay, combine like terms, REY plus a negative 1,000, 500 plus 500 gives you 1,000. And then to get REY by itself, I'm going to add 1,000 to each side. REY is equal to 1,000 pounds acting upward, or being able to support upward. Okay, next force, or the next step I should say, so we're going to be still working with forces, but I'm going to do step 4, which is called sum the X forces. Okay, as I take a look, X direction forces, so we're going to go through again, we're going to kind of assume, we always want to assume these forces are going to be positive, so I'm going to take a look at the sum of the forces in the X direction add up to equal 0. REX plus RDX is equal to 0. Those are the only two X direction forces I have acting on the truss structure. So now REX is what we're looking for, plus a 1,500 pounds from RDX that we solved for. And in order to go through and to put REX by itself, I'm going to get a negative 1,500 pounds, which, again, as noted in a previous video, I guess I'll put that up here, 1,500 pounds. It's just indicating a different direction. So it was positive when it was going to the left. We ended up, again, assuming REX. We always want to assume that that's a positive value that we're generating. And here we're going to get negative 1,500, or meaning it's going to go in the opposite direction of our roller, as what our roller's acting from. Okay, this is going to end out part 1 of this number 5 for this truss. And in the next video, we're going to start looking at step 5 called method of the joints and solving for the individual truss members.